Hello everyone, for First Updates Now, I'm Tyler Olds and you're watching Behind the Bumpers. It's a fun show where we dive into FRC robots and what makes them work. And today I'm here with team number 5927 Globetrotters out of Zeeland, Michigan. 5927 started in 2016 and the last few seasons have really started to perform at a high level with 4 district wins, including a win last year at the St. Joseph District event at First in Michigan. And today I'm here with Ryder and Jeremiah, and we're taking a deeper dive into their 2020 robot, some of the components and mechanisms that they have created, and then how they're tackling the 2021 at-home challenges.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
If you're on an FRC or FTC team and you're currently meeting safely in person and have a functional robot, we'd love to have you on our Behind the Bots or Behind the Bumper segments. Go ahead and reach out to us on any of our social channels, on Discord, or send us an email at admin@firstupdatesnow.com, and let's get your team scheduled to be on First Updates Now. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. So, Ryder, we're going to be starting out. Of course, this is your 2020 robot, so we'd love to hear a lot of the different features for the 2020 challenge as you tackled it. We're going to start out with the intake, so tell me a little bit about what you've done for your intake and maybe some of the iteration processes behind it as well.
All right, so if you look down here, we've got these aluminum tubings as supports for our intake here. They are controlled by these 2 servos on each side, and those will control it going down to be able to get the balls. And we've got all these mechanisms on the front to be able to pull and rotate the robot in, rotate the cells in, and then they will be pulled up by these tubes here and right up through there, a lot faster than that. And then it goes right in onto the index.
So looking at this intake here, was this your first design that you came up with, or can you tell me about some of the different design processes or different maybe concepts that you had for an intake?
This was, I believe, one of the first that we came up with. It wasn't the first one we wanted to go with. There was much larger ones where they stick out farther to grab the more cells faster. And we prototyped some of them, and we decided that this one would be the fastest and the easiest to repair and work on to get the best robot functionality.
Tell me a little bit about the blue mechanism wheels that are up by the poly belt there. What are those used for?
These ones currently aren't doing a lot, but if the ball were to get stuck on either of these 2 sides, they would kind of help push it back towards the center to go right into the index nice and.
Have you had issues with power cells jamming, and if so, how have you tried to mitigate that?
We've had a couple issues. If it's in the middle of a match and one of them does get stuck, we do have a reverse function programmed into our robot to be able to kind of push them back out towards the front to be able to get them nice and straight in.
Sure, that makes a lot of sense. So Jeremiah is going to be talking about your indexer that you have, and I know it's pretty tightly packed in there, but I'd love to hear about just how you're getting that transfer between your intake into your shooter.
The transfer between the intake and the shooter, there's this 3D printed, can't really see it that well, pulley right here that has the poly belt going over it on the bottom, Teflon so it doesn't scrape on the aluminum, Teflon here so it flows smoothly and goes under. There's also Teflon on the sides and top rails so it goes in and does not get like stuck or multiple of them get pinned up in a corner. We have some grip tape on the sides of this pulley so it pulls it in so it does not get stuck and so it does not like slide across them and it gets stuck because the belt is below the edge and it's too much of a dip. Otherwise, the grip tape or the plastic will not pull it hard enough to get it in.
Is there compression on the power cells when it's, that's what I wanted to see there. So how much compression are you putting on the power cells right there?
I don't think it's a lot, maybe half an inch. Nah, it's almost completely free floating in there. On the other side, there is a pre-shooter that brings it from the flush right inside here. There's a ramp that pulls it up, and then 2 wheels here, a set of wheels here and here, that will pull it up into the pre-shooter, so then it's up there rather than on the ground, flush.
So from the pre-shooter on there, is where that's driven, is that more towards the shooter assembly itself, or do
It's
you actually consider that part of the indexer?
it's between them.
Yeah, fair enough on that. So, well, why don't we talk about the shooter then, and talk about how the power cell gets from your indexer with that pre-shooter and then into your shooter, and then talking about some of the design. We don't see too many teams that are going with potentially two powered flywheels, is what it looks like on there, though I could be wrong. So, love to hear about that thought process on there, and obviously it's been successful as you had a district win last year with it.
Yes. So from the indexer there, we've got these four grippy small wheels that are attached on a thunderhex shaft that essentially pull the power cells forward to meet with these other three on the side, and then those two together will push it up towards these wheels, and then once one of these wheels can grab it, it goes right on through. We have this lower one running at a faster speed than the top one, as to create a little bit of backspin on the cells as they fly through, to essentially add an easier, smoother arc to go into the goal.
And since you're direct driving those, what does that look like from the after you shoot a power cell? How long does it take for it to get back up to speed in order for you to shoot another power cell and not lose any potential velocity or distance on it?
Not too long. We can usually get them within a half second or so.
Okay. Makes sense on there. And then tell me a little bit more about your turret. What's your range of motion on it? And also, like, where do you shoot from typically during a match?
So for our turret, we've got a 360-degree motion. We don't usually use all 360 degrees. If we were closer to the goal, we'd be shooting around 90 degrees. And the farther we get, we can kind of spin it around. We usually use about that radius to shoot.
Sure.
And then we usually shoot from the edge of the trench closer to the goal. And then also, again, depending on where we shoot from, we've got this screw bar, and I'm not sure what this is called.
Sure, like your lead screw on there?
Yeah. And this is attached to a little Neo 550 to apply different heights for this, so that if we're closer to it, we can kind of give it more of an upward shot. And then if we're a little bit farther away, we can go more angled forwards to get it nice and into the goal.
For your angle adjustments on there, is your Limelight connected to that in regards to determining that angle, or do you just have some pre-programmed settings, or is it completely manual?
We've got pre-programmed. I believe it is also manual if we need to. We do have pre-programmed spots to be able to shoot quick and easy from. The Limelight just controls the turret part.
Yeah, sure. And where are some of those spots? Where does your team typically like to shoot from, or where have you found the most success?
We've found the most success from the edge of the trench, so we typically shoot from there every time. The other ones don't use as much.
And we'll be talking a little bit more about the at-home challenges in just a moment as well, too. But I guess the lead into that, how did you adjust this robot for the at-home challenges? I know, you kept the same components and that sort of thing, but I would think some of the programming and some of these shooting adjustments would probably have to be made for that, right?
Yes. So for the shooting challenges for the at-home, essentially what we did is we ran through and picked and put the robot where we needed it to be to shoot, and then set this, find the angle that we needed to shoot from, and then program those as the spots that the angle can be at. And then we just have the Limelight to auto aim our turret the whole time.
Sure. And Jeremiah, I want to talk to you about this climber that you have. And once again, climber not used for 2021, but we are still highlighting 2020 robots since a lot of it got cut short. And it's hard to tell sometimes from my angle, but I do get excited when I see robots that might have wood or some sort of composite like that on there. So is this actually made out of wood? And tell me a little bit more about some of it as well.
It's made partly out of wood. The arms are wood, but the arms only job is to bring the hook, which is over here, up to the top of the bar.
Sure.
The hook hooks on, and then we have a winch that pulls the cable and the hook down, and the arms are just there for support to get it up there in the first place.
And your winch doesn't detach or anything, right? That stays on the whole time?
No, the winch stays on the whole time, but the winch releases to bring the arms up, and the arms are powered by gas springs in the corner, so they automatically go up
Sure.
when released, because they are held in place by a servo motor in the very back of the robot that holds the ends down. When this thing releases, the arms shoot up as as tension is released on the cable. And when they get to the top of their span, the robot drives forward and the hook moves to connect. And then the winch takes over all the rest of the work.
So one thing I just want to ask you as a follow-up on this, with wood, I'm always curious why teams would choose to use plywood. Sometimes it's cost, sometimes they just found something that this material works best for what they need it for. So where does your team fall in regards to why it chose to use plywood essentially for this mechanism?
I think we chose plywood because aluminum was heavier and harder to work in. Plywood, well, we had wood and we designed it for the width and all that stuff. Slightly lighter than aluminum, or not really lighter, just thicker.
Sure. So if you use aluminum, essentially you'd be adding just that much more weight, right?
Yeah.
Yeah, totally makes sense on that. I'm always fascinated. I always love to hear the stories behind that as well. So let's wrap up in talking about, I know you have something on your chassis that you want to talk about that was custom, or that you made custom made for it as well too. And then Ryder, anything else from the at-home challenges that you want to mention that you've been trying to tackle with your 2020 robot, and anything that you're looking at doing for the future as well?
All right, so with our chassis here, in each of these corners by the wheels, we've got these aluminum tubes, square tubes, and inside of those, to connect them strong, we've got these little things we like to call dog bones. And they essentially sit in nice and tight in the tubes, and then we can just screw bolts straight into it, and they keep them nice and secure. And that's how they're connected on all of these corners and connections here.
Sure. And then for at-home challenges, looking at it, we talked about a little bit from the shooting challenges, but have you tried to accomplish any of the other ones? How has that worked out for your bot? And then anything you're looking at making modifications for the future as well?
Yeah, so for the at-home challenges, we've decided to stick with shooting and teleop driving as our base challenges. And so most of these practices that we've had, we've just been running a lot of laps of teleop, tracking our times, getting better times, getting faster and smoother for each of the 4 courses. Shooting has probably been done a little bit less than teleop, but we have been mostly just practicing the smoothness of the transitions in taking shooting and the correct spots to go.
5927, thank you so much for taking the time to speak to us about your robot and your team. Obviously, you've had a lot of success the last few years in Michigan, so a great up-and-coming team out of Michigan. Can't wait to see, of course, the rest of this year. Never know, we might get an off-season challenge or two or competition, and can't wait to see what you do in future years. Good luck, and thanks for taking the time. Thanks for watching. If you want more fun content, be sure to subscribe and ring the bell to be notified about our latest videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content.